Okay, this is going to be the end of the year a review video for pre-calc AB. We're going to be going over this video in three parts. Part 1, Part 2, Part 3 covered over these next 3 weeks. So I want to go through this. All right, so you should have a copy of this printed out. Okay, all right. So I'm going to go ahead and start with question number 1. All right, and they give us an arithmetic sequence of T1 being 4, T2 being 16. Okay, so the answer to that first question, difference between that would be 12. Okay, the next 4 terms, all right, pretty simply, this is what you'd have: 1, 2, 3, 4. You're just adding 12, so that's 28, 40, 52, and 64. Okay, the explicit formula. The basis of the explicit formula is this, okay, where A1 is the first term, which would be 4. The difference, which we already said would be 12. Okay, and if you that sometimes can suffice if you wanted to distribute that out and combine your like terms. This would be your explicit formula, okay? All right, pretty simply that. The recursive formula, okay, you learned this from Algebra 2, is this a to the n minus 1, which means previous term. The previous term adding 12, all right, where n is greater than or equal to 1, okay? Define the sum of the first 125, okay? You use the formula. Okay. Now, we know that there's 125 terms, so that's our n. Okay. We know our first term, which is 4. What we don't know is an. Well, if they want the first 125, what I can do is take 125 and put it into that. So 12 times 125 minus 18. Okay. That will give us 1492. Okay. If you use a calculator and figure that all out, your sum ends up being 93,500, okay? The last question for question 1 is Sn is 7704, find n. So what we're going to do is we're going to come back to this formula. So we know 7704 equals n over 2, all right? A to the 1 plus an, all right? All right. Now, very simply, to help us solve for n, let's cross multiply that. Which that would be 15,408. Okay, let's talk about what we know in a second. All right, so we know A1 is 4, and we do know this AN. We know that AN is equal to this. So I'm going to go ahead and put 12n minus 8 in here, and if we recombine those like terms, that would be 12n minus 4 equaling this. Okay. Distribute, you get 12n squared minus 4n equals this. So this is a quadratic, so you would move that over. Okay, if you use a calculator or you use Desmos, okay, you can factor that or solve. There's 2 solutions. One is n equals 36, and the other is n equals like negative, I think, 35.6. Well, the only obvious answer would have to be that. So the number of terms is 36. Okay? So that is question 1. Okay. Let's go on to question 2. Okay? Question 2 is a geometric one where they tell us T1 is 20 and the ratio is 0.5. They want the next 2 terms. Okay? So it's 20, 1, 2. So I'm multiplying by 0.5, so that'd be 10. And then that would be 5. Okay? The explicit formula for geometric is this formula right here, where we know the r and we know the rate, which is a half. Okay, so that would be the explicit. The recursive formula is just that an minus 1 times 0.5, where n is greater than or equal to 1. Okay? The sum of the first 12 terms. Well, the formula for the geometric says that the sum of n is equal to a1 times 1 minus r to the n, okay, all divided by 1 minus r, all right? Well, if you put that in, we'd be 20, all right, 1 minus 1/2 to the 12th power, all divided by 1 minus 1/2. What I would caution you is figure out this top part and then divide it by 1/2, and what you'll get there is you'll get like 39.99, okay? All right, the next question, does it converge? Yes. Okay, if your r is less than or equal to the absolute value, or less than the absolute value of 1, then the series will converge, okay? All right, the series will converge. And the next question was that idea as n approaches infinity. Well, the idea is there is a formula for that, which basically says of an infinite series, okay, your first term, 1 minus your rate, so 20, minus 1 minus 1/2, so 20 divided by 1/2 would actually be 40. So that's actually going to be your limit there, okay? Make sure you guys are getting all that in there. Yeah, great. Okay, find the sum of the nth, all right, power, all right? So the idea there, okay, is that if we use this formula right here, okay, and we say that the sum is 3984375 equaling to 20, all right, times 1 minus, all right, our 0.5, all right, to the n power, all right, all over basically 0.5, okay. Here's what you would do. You would, because 1 minus 1/2 is 0.5. So I cross multiply that, okay, all right. I would get, and then after I cross multiply that, I would divide it by 20, okay. And what you would end up having is 0.99609,375. So cross multiply that, okay. So I cross multiply this and then divide by 20, okay. That would leave you with that, so I'm left with this, okay. I would subtract 1. What that ends up being is negative 0.00390625 equaling negative 0.5 to the n. Well, if I just divide the n's out by negative 1, okay, I would get 0.00390625 equals 0.5 to the n power, okay. The way we solve this is through a log, okay, so I would convert the log. So my base would be log of 0.5 with this big number right here equaling n. So if you type log of 0.5 with this big number n, you'll get that it's 8. Okay. What value does r have to be for it to converge? To converge, the r has to be less than 1. Absolute value. Okay. So those are the two long question number 2s. Okay. From that standpoint, let's go on to question number 3. Some of these I'll be able to have more control over the board. All right. All right. Question number 3. All right, is partial sum of k is 1 from 5 to 2k squared plus 4. The concept with this is you put this in here, so it's 2, 1 squared plus 4. All right, so that would be 2 times 1 plus 4, so it's going to be 6, okay? And you continue that process, 2 times 2 squared plus 4, all right, that'd be 2 times 4, all right, plus 4, so that'd be 8 plus 4, which would be 12, okay? All right, and you continue the process on, all right? The next number, if I were to put in 3 into there, it ends up being 22. And then if I put 4 in there and calculate it, it ends up being 36. And then I put 5, because that's my stopping point in there, that'd be 54. If I add all those up, I get 130, okay? I don't think I need to show every calculation, but that's basically how you would do that, okay? The 3 trig identities that we talked about, the Pythagorean identities, is sine squared plus cosine squared equals 1, okay? 1 plus tangent squared equals secant squared. 1 plus cotangent squared equals cosecant squared. Okay, always remember C and C. That's how you could remember that if you need to. Okay, question number 5, some of the solving ones. Okay, all right. What I would do here, okay, is I would replace cosine with, let's say, A. So cosine of x will equal a. So I'd have 2a plus square root of 3 equals 0. I would move that over here, which would give me negative square root of 3 and divide by 2. That's a is negative square root of 3 over 2. I put the cosine back in here, all right, and figure out what that would be, okay? We'll do a whole thing on the unit circle, but basically for cosine to have be square root of 3, that's 3, 2, 1, right? And so that would be a 30-degree triangle, or a pi over 6, okay? All right, so the question is where would pi over 6 for cosine be negative? Well, that's going to be here and here, which would be 5 pi over 6 and 7 pi over 6 being your answers. Okay, 5b, okay, 5b, same thing, I would replace a with sine. So that's going to be 2a squared minus 1 equals 0. So that's going to be 2a squared equals 1. A squared equals a half. Square root here, all right, what happens is that's going to be plus and minus square root of 1 over square root of 2. If I rationalize that, okay, that's going to be a is plus or minus square root of 2. This would be square root of 4, which would turn into 2. Okay, so all right, now if I put that back into play, when is sine of x plus or minus square root of 2 over 2? Well, if you go to the 45-degree triangle, all right, that's we know that. Okay, so that's the 45 degrees or the pi over 4. Since it's plus and minus, then all of the pi over 4s, triangles, will be the ones that will work there. Okay? Question number 6. All right, this is pretty easy. 6a, 1 over tangent of x would be equal to cotangent. The b part, 1 over cosecant of x, is equal to sine of x. Okay? 7, explain why that this is undefined. Well, the reason is the range for sine, okay, is between -1 and 1. All right, we did that through our graph, if you remember. We did something like this. Well, the idea was these spots are between -1 and 1. Okay, question 8, okay, we've drawn this picture, I'll draw it up here before, that all things would be positive here. Sine and cosecant is positive here. Tangent, cotangent is positive here. Cosecant and secant is positive here. So this is quad 1, quad 2, quad 3, and quad 4. Okay, so where is sine positive? Sine will be positive in 1 and 2, and that's the same thing with the cosecant. Okay, all right, cosine will be positive in 1 and 4, and that's the same as secant, and tangent will be positive in 1 and 3. Okay, all right, that's the same as cotangent. Okay, so we're able to get a lot of those through. Okay. All right, question number 9. Okay, you're doing pretty good here. Okay. Question number 9 is find the tangent of sine inverse of -8/9. So what you would do is draw this little triangle here. We've drawn this all year, where this is the hypotenuse, the opposite, and the adjacent. This would be opposite, and this would be the hypotenuse. So I got 8 and 9, okay? If I do Pythagorean theorem here, okay, all right, that would be the adjacent squared plus 8 squared equals 9 squared, 64 and 81. That would be 17. Square root of 17 would be the adjacent side. Okay, square root of 17, okay? So they want me to find tangent, okay? All right, well, we know, we don't really know what could be positive or negative in this, okay? All right, because this part could be negative, it could be positive, so our answer would be plus and minus, all right? 8 over square root of 17. If I rationalize that, that would be 8 square root of 17 over 17 with the plus and minus. All right, once again, reason why we need plus and minus, we don't get enough information about what that would be from that standpoint. Okay, going on to the last page, page 10, question 10. Find the exact value of sine of 105. What I would do is use your identities your identities worksheet. Okay, there's an identities formula sheet that basically says do sine of 60 plus 45. Okay, all right, and that formula would be sine of A, cosine of A. I'm sorry, sine of A, cosine of B, plus cosine of A, sine of B. Okay, so now I've given you that. If you want to work through it, pause the video, you can. The idea with the 60-degree triangle, would it be that? So it'd be square root of 3 over 2. All right, the 45-degree triangle, square root of 2, square root of 2, and 2. Okay, so it'd be square root of 2 over 2. Cosine of that one would be a half. Sine of that one would be that. So what I got is square root of 6 over 4 plus square root of 2 over 4, which just gives me that. Okay? All right, find the exact value of sine of 15 degrees. Now, there's a lot of ways to do this. I would do this through a sum and difference. I would just do 45 minus 30. Okay, so our 30-degree triangle. Okay, that would be sine of A, cosine of B, minus cosine of A, sine of B. Okay, the sine of this would be A, this would be B. Square root of 2, 2, square root of 3 over 2, minus the cosine of the A triangle, which would be 45, which would be square root of 2 over 2. Sine would be a half, so it's square root of 6 over 4. Minus square root of 2 over 4, which pushes together as those. Okay? All right. Moving on to question number 12. Okay. Question number 12 says if cosine of A, here's my A triangle, cosine, adjacent, opposite, hypotenuse. We know through the Pythagorean triples, those would be 7. Okay, the sine of 1/2 A. Okay, if you use that formula, which is square root 1 minus cosine, all right, of A all over 2. All right, so it'd be 1 minus 24 over 25. Which would be 1 over 25. And if you divided that by 2, that would be basically square root of 1 over square root of 50. If you separate that out and rationalize and reduce, that will eventually be 5 square root of 2. This would be 50. Okay, so that would be plus and minus 1/10 square root of 2. Okay, all right. And for 2A, sine of 2A, okay, that formula is 2 sine of A, cosine of A, so it'd be, sine would be 7 over 25, cosine would be 24 over 25, okay, if you multiply all that out, you get 336 over 625, okay? All right, moving on to question 13, the last question of this packet for this week. As I said before, we'll have multiple ones each week, okay? All right, what I would do, the first thing that I would do with this is I would take out cosine. Okay, I would take out cosine and replace it with that trig identity. What was that trig identity? Well, we know that cosine squared equals 1 minus sine squared. So that goes right in here. If I distribute that, that's negative 2 plus 2 sine squared minus sine equals negative 1. All right. If you want to replace now sine with, let's say, A, this would be negative 2 plus 2A squared minus A equals negative 1. Since it's a quadratic, I want to bring everything back. So 2A squared minus A. Okay. If I add this one back here, this would be negative 1. Okay. If I factor that, okay, I would have minus 1 plus 1. Okay, so I got 2A plus 1 equals 0. A minus 1 equals 0. So A equals 1. This would be A equals negative 1/2. Bring the sine function back. Okay, so the question is where is sine negative 1/2 and where is sine 1? Okay, Well, once again, 1 over 2, that'd be a 30 or a pi over 6 triangle. All right, where is that going to be negative? It's going to be in those. So that would be like 7 pi over 6, and that would be 11 pi over 6. Where is sine 1? The only spot sine would be 1, and we've labeled that before, would be the pi over 2 area. Okay, so that would be the 3 answers, all right, for that. Okay, moving on to B, C, and D here. As you can see, all right, I'm just going to erase this one because there's some similarities in B. All right, what I would do is now I would replace sine squared with 1 minus cosine squared, just like that other identity. All right, and so you have something very similar here. Okay, this would be 2 minus 2 cosine squared minus cosine minus 1 equals 0. I would replace cosine, so it would be 2 minus 2a squared minus a minus 1 equals 0. All right, that's negative 2a squared minus a plus 1 equals 0. I would divide out this negative 1 to make it easy to factor. Okay, and that would factor to 2a, all right, minus 1, 2a plus 1, so or a plus 1, very similar, okay? All right, so then 2a minus 1 equals 0, a equals 1/2. This would be a plus 1 equals 0, a equals negative 1. Bring back the cosine function, okay? Where is cosine negative 1? The only spot for that to be is pi, okay? We'll go over that on the trig side of things, okay? But that's from our trig unit. Where is it at 1/2? Well, 1/2 would be there, making this square root of 3, which would be 60, or pi over 3. So where's cosine positive? Well, it's going to be positive at regular pi over 3 and also positive at 5 pi over 3. Okay? All right. Moving on to the last 2 questions, 2 parts. All right, last 2 parts. 13C. 13C. I got sine 3x cosine of x minus cosine of 3x sine of x equals basically 1/2 square root of 2. Okay? Well, what you have to identify is that basically this is a sum and difference formula. And what that sum and difference formula, it is a sine A minus B formula. So that means sine of 3x minus x equals square root of 2 over 2. So I got sine, if I subtract that, of 2x equaling this. Now what I'm going to do here to deal with these little half angles and double angles, I'm going to sub out that a as that. So I would say, okay, sine of a is square root of that is that. Well, when's that going to happen? That is going to happen at pi over 4, okay, being positive. Sine will be positive in this quadrant, this quadrant. So the A answer would be pi over 4, and the other A answer would be 3 pi over 4, because you can have 2 being positive. Now I'm going to put this back in with the x, and then I'm going to divide by 2, and what that's going to be is pi over 8 and 3 pi over 8. Okay? So that is that answer. Okay. All right. 13D, pretty tricky here. Okay. What you have to realize is this is a double. All right. This is a double. So I'm going to move this over. Okay. All right. I'm going to move this over to here. So I would have sine of x, cosine of x equaling 3 over 12, which would be 3/4, or square root of 3 over 4. Now, what I would notice, okay, all right, what I would notice is, actually, hold on, we don't want to do that. Let me go back real quick. What we want to do is I want to make this into 6 times, and the reason why, all right, is that this is the same thing, okay, as sine of 2x. It's the same basic formula. So 6 times the sine of 2x equals that. Pretty tricky, I would say. Divide by 6, that's sine of 2x equals square root of 3 over 2. Same thing as I did there, I'm going to sub out a for 2x. So I have sine of a being the square root of 3 over 2. All right, 3, 2, that's going to be a 60 degree or a pi over 3. Okay, so where is sine positive? Here and here. So a would be, one answer would be pi over 3. The other answer would be 2 pi over 3. Now if I put that 2x back in here and divide by 2, that's going to be, x is going to be pi over 6. And then if I do this one, divide that by 2, that's going to be 2 pi over 6 or pi over 3. Okay, so those would be the 2 answers there. That was pretty tricky. I'm not gonna lie, that's actually pretty tricky. So that's the first part of the review. All right, if you just practice that with the identity sheet that you have, you should be fine. The next review will come out next week.